22 7B205 Doppler effect sound wave front frequency sound speed barriers. Wow Seti. There's the alien radio signal. And Doppler effect sound waves near far frequency sound speed barriers, line 22 wow data. So this is a Doppler effect model in X and Y coordinates. So it shows stationary. This is I don't know if it's from a blog. It doesn't say. Oh, that's real smart. I think it's from a blog and I forget which one, and I didn't get the link and I apologize. Stationary sound source produces sound waves at a constant frequency f, and the wave fronts propagate symmetrically away from the source at a constant speed c. The distance between wave fronts is the wavelength. All observers will hear the same frequency, which will be equal to the actual frequency of the source, where f equals fo. The same sound source is radiating sound waves at a constant frequency in the same medium. However, now the sound source is moving with a speed us equals 0.7 c, Mach 0.7. Since the source is moving, the center of each new wave front is now slightly displaced to the right. As a result, the wave fronts begin to bunch up on the right side in front of the spread further apart on the left side behind the source. So on here it doesn't show it, but when I put it up on the blog, it's going to show how the signals go. Okay. An observer in front of the source will hear a higher frequency, f equals c, blah blah blah, for the equation there, and an observer behind the source will hear a lower frequency with another equation there. And then it's just breaking the sound barrier. Now the source is moving at the speed of the sound in the medium, or Mach 1. The wave fronts in front of the source are now all bunched up at the same point. As a result, an observer in the front of the source will detect nothing until the source arrives, where f equals that equation, and an observer behind the source will hear a lower frequency of that equation. Okay, so the sound source has now broken through the sound speed barrier and is traveling at Mach 1.4. Since the source is moving faster than the sound waves it creates, it actually leads the advancing wavefront. The sound source will pass by a stationary observer before the observer hears the sound. As a result, an observer in front of the source will detect an equation, and an observer behind the source will hear a lower frequency equation. The data will continue in the next video, and I will find where this information came from before I blog it. Okay? Thank you for watching.